The purpose of titration is to quantitatively determine the concentration of an unknown solution, commonly called analyte, by adding a volume of a chemical with a known concentration called titrant. And to mark the endpoint of titration, each of these pH indicators will be added to the analyte that will be in this flask, Erlenmeyer flask. There are many applications of this technique. For example, in the wine industry, titration plays a key role in bringing out the flavor of the wine. Additionally, the flavor of various wine brands and types corresponds with the amount of acidity in them. To get more information about the use of titration in the wine industry, click on the link in the description of this video. So, to get started, I want to make sure I have assembled my titration apparatus, and I will take the opportunity to show the materials that we will use in this experiment. Let's start. The first step is to fill the bead with sodium hydroxide, which will be the titron. Okay? The titron. Guys, just to remember, if the stopcock is perpendicular with the glass, it's closed. If it's parallel like this, it's open. Okay? But as I'm not sure how clean my bead is, I will rinse the bead with a little bit of sodium hydroxide to remove any impurities, moisture or acid that might be in here. Okay? In other words, I'm doing this to remove anything that can change the concentration of my titron. Okay? Drain it out. I will make sure that my bead will be clean. Okay? I'm going to refill the bead with sodium hydroxide, with the titron, and repeat this process 2 more times. Okay? It's a good laboratory practice to rinse the bead thoroughly with the titron. Now my bead is clean and I know that has only sodium hydroxide in here. Okay? Now I'm going to fill the bead with sodium hydroxide, the titron, above the 0 mark. Okay? Note that the markings on the bead go from lowest at the top to highest at the bottom. And this bead holds 50 milliliters. Okay? Now, let me get the beaker. I'm going to put here. I'm going to let it out a little, so the bottom of the meniscus, it sits on the 0 mark. Okay? It must be done at eye level. Done. Okay? Now, my titrant is ready. Now, let's prepare the analyte. I'm going to transfer 20 milliliters of hydrochloric acid to the Erlenmeyer flask. Okay? Using a 20 milliliters volumetric pipette. It's been calibrated to exactly 20 milliliters. This is 4 significant figures. 20.00. Guys, the uncertainties of the materials used in this experiment will be available in the description of this video. Now, I'm going to insert the pipette filler here. Be careful. Always hold the pipette as close as possible to the tip where you will insert the pipette filler. Never hold here on the middle, because if you apply too much force against the pipette filler, you could break the pipette and the glass could seriously hurt you. Never do that, okay? Now, I'm going to drain up the liquid, the hydrochloric acid, and transfer to the Erlenmeyer flask. Now the analyte is ready. We have 3 here because we have to repeat the technique 3 times. We have to do 3 trials. Now, since we are using 2 clear solutions, the titrant and the analyte, we need to have something that will tell us when we have reached the end point. And this thing will be the indicator. Let's start with phenolphthalein. Okay? I'm adding 3 drops to each Erlenmeyer flask. In acid solution, phenolphthalein is clear, but in basic solution, phenolphthalein is going to turn pink. Let's start the titration. Guys, operating the burette requires 2 hands. One hand to turn the stopcock and control the flow of the liquid, while the other hand swirl the Erlenmeyer flask. Okay? You see that pink color that comes right away and then it disappears. So, you can keep adding as long as that pink color is there. When it begins to stay, then I'm going to slow down the rate. Let me wash the inner walls of the Airlame air flask. Distilled water will not change the number of moles. You can add without worry. That is the pale pink that we want. This is indicating the end point of the titration. Now I have to read the burette to see how many milliliters of titrant have been added to neutralize the analyte. 27.9.